My name's John Papa, and they asked me to come talk a little about building web applications with Angular and deploying them to the cloud. And this talk is less about the technology to build the applications than it is about how you take that application to the next level. Like, what do you do once the application is already built, and what are the things you have to consider before you actually deploy it to somewhere on the internet? So the idea is, when we're done with developing code, we generally like to think, okay, I'm done, just ship it, right? It works in my machine, hopefully it'll work everywhere else. That used to be true when all we had to do was put a script tag in a web page and call it a day. Now we have modern JavaScript, which does a lot more for us because we get to do a lot of build processes. There's things like TypeScript and Babel. We've got tree shaking and all these other cool names and things out there in the web. But basically, it turned our JavaScript world from just a script tag into something that's a little bit more powerful, but also more complicated to build. So how do we take advantage of those build features, but still end up making it easy to port ourselves up to the web? So the idea is we first want to optimize our app. When we're done writing code, we want to make sure that what we have works in a lot of places. And some folks might say, well, why is this that important? When you're writing a demo, which is what you see at a lot of conferences, you see a demo and the demo is small and you can put it on your mobile device. You never have to optimize anything. But what happens when you have a really large scale application and you have a mobile device and it's really slow internet connection somewhere? You've got problems. Do you want to be shipping your 25 meg JavaScript files across the wire? Probably not. So we want to figure out how to optimize some of our Angular apps. And then what are the build options that we have and how do we take advantage of those so we can make those builds even smaller and faster so we get the best performance possible? And the last piece is, how do we deploy our application? How do we make sure that I'm running on Windows version 7, you're on Windows 10, or you're on a Mac, or you're on Linux or Ubuntu? How do you make sure that it all works no matter where you go? Everyone ever hear of works on my machine? Well, I want to make sure it works on everyone's machine. So we got to create stickers for that. Works on every machine. All right, so let's start off by talking about how we build Angular. Step one, we're done with writing our code. How do we build this? A lot of people talk about the Angular CLI. React's got one as well, so does Vue. They're awesome. They let you generate new apps. We can scaffold them with options like this. So we're creating applications, we're adding routing in at the beginning of the application. We're adding in styles like using Sass. We're also putting a bunch of other features on here. One of the really nice things in the modern CLI is they'll give you this dry run flag. A lot of times we'll generate applications and you don't get exactly what you thought you were going to get. It generates 30 files, 10 files, 50, however many it's generating. And then afterwards you're like, you know what? I didn't really want those options. Let me go into my folder, delete everything, and start all over again. The nice thing with the dry run flag is when you're ready, you can just remove that. If you put the dry run flag on, it won't actually generate the files. It'll just tell you what it's going to generate. So it's a nice way to kind of get a glimpse at what you're doing. I like to call it practice. So generating an app's nice, but we can also generate new code too. But the real power in these CLIs is not the code generation. We can all write code. We're all developers. Writing code's easy and the fun part. The not so fun part is creating a build process that works. So when we start thinking about personas of the build, I like to think about this from the user standpoint. We write code for people, not for the computers, not for the technology. It's for people to consume. At the end of the day, we have to make sure we understand what these commands are doing and who they're targeting. So think about who you're targeting when you run a build or when you're a developer. You are the persona. Your developer persona is, I want to write my code, see to my browser. Make changes, see to my browser. Make more changes, see to my browser. I want to do this maybe 100, 1,000 times a day, depending on how long you sit at your desk. You're going to eat or something or get any sleep, do it all through the night. When you do this dev cycle, it's really important that when you're building, it's not taking a half a minute, 2 minutes. Because when you make a code change, do you really want to wait that long? Not really. So the important part in the first persona of a developer is speed to the browser. From the point where you're writing code to seeing it in the browser. Do you have to worry about bandwidth there? No. It's all local on my machine. I am the server, I am the client, everything works great. So I don't have to worry about making it smaller. A 50 meg JavaScript file is perfectly fine. Don't really want to go that large, but you could, right? Well, what's the other persona? When you build for production, your persona is no longer you. It's not the developer. This is for the customer, for the user, whoever's going to use your application. So in this case, we set flags that optimize for that persona. Is the dev debug cycle worth it for them? Are they going to build 1,000 times? No. They're going to take the build from one time and use it many times. So in this case, the important thing to them is not dev debug repeat. It's going to be get the thing as small and as fast as possible so we have the time to first interactivity to be as small as we possibly can. Take the application, deliver the piece that they need to see in the browser as quickly as possible, and then light up other features as we go. So 2 different personas, 2 different build cycles, and all the different CLIs have something like this. With Angular, out of the box, they give you 2 flags that help you do this. -- prod is for production, and there's a newer flag called build optimizer. And we'll explore what these different things do, but you can just think of the prod one as basically saying, I'm going to make it as performant as possible, and the build optimizer adds a little extra sugar on top, which is relatively recent. So we get things in here like environments. We go to prod, the difference between the personas, we get an environment for a production environment versus a client at a build time. We get cache busting. We want to make sure that when we're writing in developer mode that we're just putting the files out, but when we go to live production, we want to have some kind of a file extension at the end of each file so there's no caching of the browser involved. Nobody wants to call every user in the world of your application and go, hey, you know what, just clear your cache and refresh. Doesn't work out so great. So cache busting is a great way to do that. Source maps. A lot of these things can be flipped on the bit if you want to change them, but by default, a developer build, I want source maps. I like to debug my code. It's one of the things I really enjoy doing. When I go to production, it shouldn't need debugging anymore. Just turn it away. Why? Because source maps are big. We don't want to be sending anything down to the client unless we need to. Then we get other options like uglification. Basically taking all of your code and reducing variable names to be as short as possible. Reduces the size, gets rid of white space, also called mangling. Bundling is another one. Take all this code and put them into single files. All of my code might be in 1,000 files, but when it goes to the browser, it's just one big file. Code splitting. This is the idea of taking your code into logical units and splitting them out. Why would you want to do this in production? Because maybe your app is really large, and as you go from different places in your application as a user, you start lighting up features on demand. I go for the home page. Just load the home page of my application, my dashboard. Don't load the admin area, the employees area, the HR area, unless somebody goes there. It'd be nice if our application could just figure out how to split our code into logical units so that it just lights up as we go. And what does this really do? It means the time to first interactivity is going to be shorter because all you're loading on the first load is that little bit that needs to make the application start up. So code splitting is really nice. Hard to do on your own, but the CLIs will do this for you. This one's specific to Angular. It's called ahead of time compilation. So these are ahead of time templates. Basically, at a production time, Angular will go through and it figures out, if you turn this on in production mode, it'll figure out, okay, I'm going to compile all your templates on the server while you're building. This does 2 things. It means I no longer have to compile it in the browser because the browser is slower than the server is, right? So that means there's less to do in the browser for the user. That's faster. And it doesn't have to send as much across the wire because the Angular compiler no longer has to go to the browser to do compiling. Let's put this another way. Imagine you have 1,000 users of your site. Would you rather have all 1,000 of them compile the application every time they hit it, or would you rather have it happen once in the server? So ahead of time, we'll do that for you with Angular. And then more modern things it'll do, like tree shaking. This is where the build optimizer flag comes in. Out of the box, the AOT flag does a little tree shaking. The build optimizer will do even more. I like the name tree shaking because it gives me an opinion of when I was a kid, I used to go to the apple trees and I used to shake those little tiny ones, not the big ones, but shake the little tiny ones and like some of the apples would fall out. That is, imagine this tree is your code base. And all the apples are different pieces of your code. The ones that fall to the ground are the dead code in your app. We all write code and then later on we refactor. And sometimes there's code that's just never going to get run, never get executed. So tree shaking figures out through your dependency chains which code can I drop out of your app and not include in the bundles. So all these things are things we never really thought of in the past, but these CLI tools like Angular's will help us make the build smaller and faster. So let's take a look at how this would work inside of an Angular application. I'll give you the links towards the end too to all the code that we're sharing in here. All right, so here is an Angular application. And up top, we've got our client folder, and I've got a server folder running Node. And you can see here I've got my title, running Cosmos DB on Azure. Now what I can do with this app is I can run my build process. So inside the terminal, and I'll use the built-in terminal here, and I'll make that a little bigger, we can run ng build. Now when I run build, it's going to go through and look at my application, and it's going to build it without all those production optimizations that we normally want to get. So it goes through, uses Webpack behind the scenes, and it's building up my app. And you can see different files that get output. The inline bundle, the main bundle, polyfills, styles, and vendor. The inline bundle is the piece that's using it to bootstrap your app. That's basically Webpack saying, here's how I get started. It's very tiny, takes care of business. The main bundle is my code. It should just be called my code bundle. It's everything you write goes in there by default. That we have a lot of control over. Polyfills, it's kind of big, it's 200K, give or take. That is code that you also have a little control over depending upon who your target browsers are. If you know which target browsers you have and you know what your users are using, then you can reduce the size or increase the size of your polyfills based upon which browsers you need to support. By default, it's supporting quite a few here. Then you get your styles, and then you got vendor files. Vendor files usually end up being pretty big, bulk of your application. Out of the box in this one, it's 2.3 meg. That's unacceptable for a demo app with 2 components, quite frankly. This is demo code. All right, so out of the box, yep, Angular gives us all this. What happens when we flick on the prod flag? Well, now it's going to run through the same files and build up the application. And it's going to do a couple extra things. Remember that chart we just looked at? It's going to put the cache busting on there, so the file names will change slightly. And our sizes should change a little too. This is a small app, so we're not going to see huge differences. Notice the polyfills went from 200 down to 66K. 140K of savings there. Not too bad, right? About 25% down. 75% off of it. Then we go down to the vendor, 300K. So we went from 2.3 meg down to 300K. Knocked 2 meg off that application. That's pretty significant right there. And I think this application is mostly using Angular and RxJS features at this point for third party. And then the main bundle went from 31 to 18. You're like, 13K, not a big deal. But imagine that that app was much larger. You know, that's like a 40% savings right there. So you've already shaved quite a bit off. But what more can we do? But wait, there's more. So the Angular team built this other flag called Build Optimizer, which I never spelled correctly in any demo. So let's see if I did. I think I did. I think they just didn't want a flag called BO. So that would have been kind of cool. All right, so this is going to go through and do the same production build and all that. And then it's also going to do a little bit of smarter stuff with the tree shaking to figure out what other dead code could I possibly get rid of. The first thing that you might notice is, wow, it completely got rid of the vendor file. That's how it makes it smaller. It actually just merged it with the main file. So it looks like Angular threw away the vendor file. But now the main file on the bottom, 268K, we look at that compared to the vendor file and the main file up top, 334K. So we lost quite a bit more out of our application just by turning on the tree shaking features in the app. So the good news is, out of the box, we can run all of these flags and get quite a bit for our application. But there's more we can do. This is just automated tooling. There's other options that we have as well. Let's go look at some of the source code. And we'll close that down. So I'll show you a couple places that you really could save your application. Now, the first one would be in a module. Let's say you're inside of a module like this with Angular, and you're importing all the stuff that you're using. Angular is smart enough to know if I pull in the Forms module up top there, and I'm not actually using it, it'll figure that out through the tree shaking that, you know what, you're not using this, I'm going to remove it. So that Build Optimizer takes care of it, which is great. But what happens if Angular can't figure it out on its own? Well, let me show you a time where it has problems with this. So here in this app, and there's new syntax for this, but I want to show this just to give you an idea. Let's say I'm using RxJS. With RxJS, before version 5.5, this was the syntax where we went and got operators. In I think it was 5.5. Is David in here? Is it 5.5 or lettable operators came out?
It's 5.5, but they have 5.6 now.
Yes, now they're at 5.6. So yeah, there's basically what happens in line 7 and 8 saying, go get me the catch operator, go get me the map operator. Those are strings. JavaScript loves magic strings, but with magic strings, you can't get a strong type dependency and figure out what the dependency chains are very easily. So what happens here is some people end up in their application with, I want the catch, I want the finally, I want the map, I want the do, I want the tap. And they start adding in all of these different features. And they're like, you know what, John? I don't really want to have 20 import statements in my file in every file. I'm going to make my life easier. And I'm going to do this. I mean, how many possible things could be in RxJS, right? So this is what we did in the early days of Angular, and we used to complain to the Angular team, why Angular so big? And they're like, because you're coding bad. They were right. But so going through that was easier. Oh my gosh, line 9 is so much simpler to write. But when we do this, if we run through the build optimization now, Angular can't, or the build process can't entirely figure out what's not being used from RxJS. There's like 100 and some operators in RxJS. And it pulls them all in. The size of my app is going to explode. So with tools like this, it makes it hard to figure that out. So some of the options we have is we can come down and we can run our, actually let me run a different command here. I put this into there. There's a tool called Webpack Bundle Analyzer, which allows us to look at this. And I'm going to run the build process with this stats JSON flag. So we'll go back here, we're on npm, oops, that's not the command. npm run, and it was gen stats, I believe. Let's see up there. Yep, that line. So when we run this command, it's going to do the same build without the build optimizer for now, and show the stats JSON file. This stats JSON file can then be inspected by tools so we can get a glimpse at what's inside of our application. Now we'll take a look too at the vendor bundle just to see how big it got. It's 500K. If you remember, I believe it was around 350 at the second step before. So we added 150K to an optimized build. And that's stuff we're not even using, just so I could get one line of code in there. So how do we look at this? Well, we can use this Webpack Bundle Analyzer to look at the file that we just created, stats.json. So we can run npm, run, and then it's gen report. This will take a look at that file, and it'll open up in the browser, and it shows you a bunch of rectangles. Yay, rectangles. What you look for here is you start looking at your app to see what are the larger ones. The largest ones are the ones that are showing you how large those are in your application relative to the smaller ones. So we can see our vendor bundle is pretty big. We can go over here and we can turn off everything but vendor just to look at that. We can notice like where the size of our app is. There's not much to reduce here, even though it's kind of large, the Angular core. We kind of need Angular to run Angular. But then we look over here, we look at RxJS. That is just as big as Angular, but am I using, oh my, I can't even read that. You know, look at all these operators over here. It's kind of insane. So you start drilling down and you're like, I have never heard of half of these things. Why are they in my application? So that gives you a hint right there of what to look for in your app. Generally when I'm optimizing apps, I'll look at these charts, I'll kind of explore the code, do some searching and figure out where can I make changes to my code so I can reduce this. So now as you might imagine, if I went back to my code and I reduced the size so I could actually read it, and I took that line of code out and I put the other one back in, and then we reran it, in the browser, we'd end up with a much smaller bundle in those rectangles. So let's take a look at another tool that you can use too. There's probably 7 of these on the market these days. They're all free, but what I like about these tools is you can use the top one to build, and then you can say Source Map Explorer. That's another tool that actually looks at your source maps to find what's big. The bottom one looks at the Webpack Stats, which is the one that we just took a look at. So it's 2 different ways of examining the same code. Sometimes I see something in one I don't see in the other. There's also tools out there that do like pie charts with it if you like pie charts instead of rectangles. So very, very cool tools, help you really drive down the size of your applications. Okay, so we talked about how we spent some time performance tuning our apps, but how do we make this run everywhere? I hear this all the time. I used to work at this place. And when I worked at this place, I heard probably on a daily basis, hey John, that app that I was building on my machine, it's running on a different version of Node over there and it's not working, or it's running on a different operating system over here and it's not working. And And it was like, oh my gosh, how do we make it work everywhere for everybody all the time without worrying about this? And that's where containerization kind of came out to help us. So I'm not a huge, I'm not all in on Docker for every single feature. The thing I love about Docker is I love the fact that it solves that problem for me. I like that I can just build my app and I can give it to you and it just works. So think about what we want to do. When I deploy a web app, I really want to have a script for what I'm doing. And I do this on my local machine. I'm going to install Node, then I'm going to install my dependencies. And then I'm going to run through my build assets. And then I'll build my Express server or my ASP.NET or Java server. And then I'm going to copy it all to a certain folder and get the file paths right, because that's usually a fun adventure. And then I'm going to copy it or FTP it to another machine. That's usually what I do. We use Jenkins or any kind of build process to do that. The big problem is, does the version of everything that everyone's running always work on all of these? Probably not. One of the most common things I see is, hey, I'm using Node 8.1, you're using Node 6.11, something happened, or it's Node 4, or Node 0, 10, 30. You have no idea what version people are running. What version of NPM did they install it with? So one of the things we'd like to do is automate this. If we can automate it, we can just be confident that it's just going to work everywhere. So let's take a look at how we do this with a Docker file. I think of a Docker file as that recipe that I wrote to do it locally in my machine. All the steps I did to build everything at my machine, I'm now putting them in an automated file so everybody can run them. It's a self-contained script. It has that recipe built in the app, and it allows people to configure it for different environments. So you have one Docker file that works on local machine, on your test servers, staging, QA, production, everywhere. And you just flip bits on the environment variables and it just works. You don't rebuild for everything. Here's an example of a simple Docker file. What's my platform? It's Node. What folder am I using? Copy my package JSON over, run my npm install. I can put on flags there for production or silent if I want. Build my Angular application, expose my port, run Node. Everything's in there to do what I need. And then I can configure this so I can put it into GitHub and everybody can just run it themselves. So we create the Docker file, we build it and we run it, and then we debug it. Well, hold on. We're talking about deploying. Why am I talking about debugging? I don't trust anything that says, I'm going to do everything for you and put it into a little container and wrap it up and you can't have access to it, but just trust me, it just works. And that's kind of where containerization kind of came out of, right? So let's think back now to what do we enjoy about writing code and why do we trust the code we write on our machines? A, we set up the environment ourselves. We know our environment works on our machine. So the Docker file kind of handles that. I'm cool there. B, I can look at the files at any time. If something's going wrong, I can go examine the file system. So with Docker, how do I do that? Another one, look at the logs. When I was running, can I actually see the running logs of my server? I want to look at that too, and the most important to me is debugging it. How do I debug a thing if it's in Docker? What happens? So before I can ever trust putting it in the cloud with Docker, I want to see if I can do these things locally. So let's go back to our app, and we'll close down the running app, and we'll kill all the processes. I've got a Docker file here, and it's a little longer, but the reason I made this longer is I like this thing called a multi-stage Docker file. First, I'm saying, I want to build my app with Angular. I'm going to get this Angular CLI image. And then that's got my version of Node, which is 6.11 in this case. And then I'm installing NPM, copying my files, and I'm using that really performing build process with the build, optimizer, and prod flags. And then when I'm done, you'll notice I'm just calling it client app right there on line 2. It's called a multi-stage build because I don't actually want to deploy everything in that image. That image has the source code and it's got a bunch of dev dependencies. I don't want that on my production server. Then I build my Node server, which is much simpler, and here I'm just getting the production versions of my Node modules and my Express server. And then the final one is to say, all right, now copy everything from my Node server over, and then only copy my distribution folder from my client build, the things that I actually built. So the only thing that'll be in my image at the end of the day is just what it needs to run. Nothing else. I'm not putting all this other stuff in there because I don't really want to expose all my development code and I have secrets or other things like that in there. Don't want it. So inside of VS Code, it makes it easy. We can run this command right from the command palette. We can say docker compose up, and I'll tell it to run a debug version of this. Well, what's a debug version, John? Let's go look. The debug version of this docker compose differs from the production version slightly. Now the Docker file is the same for both, but docker compose for debug, I set a node environment variable to development. And I expose the debugging ports. And I run it with the node inspector. That's the only difference between running debugging version versus a non-debugging version. I want to make sure I can actually get into it. I wouldn't want to deploy this in production because I wouldn't use that environment, and I don't want to expose that port for debugging to a live production site. So the app's up and running. All right, how do I know it's running? This is where I got stuck when I first ran it with Docker. Like, great, it's running. How do I get to it? Well, there's this cool Docker extension that you can get inside of VS Code called Docker, and you can see your containers over here. I can right click and I can show the logs. So down here now in the logs, I should see, oh look, it's running on port 3001 and there's Mongoose running against my Mongo MEAN application. I can click on that and up and running, there's my application with my data. So now I'm running my application by looking at the logs, never had to leave my editor. All right, let's close down the logs. What if I want to see what actually made it to that machine? I can attach a shell by right clicking, and now I can do an ls. And look, there's my code. I can see the files that made it over. And you'll notice there's a public web folder. That's my distribution folder for my Angular application. So I can just look into there, and there's those files that we were building for the production build of Angular. All right, that's great. So I've got access to this. Let's jump out of here. And let's debug it. So the next step is to go to the debugger. And there's this thing called a configuration for debugging. Now, VS Code has this out of the box. If I delete this right here and I click on Add Configuration, you can see, oops, it doesn't disappear on me. You can see there's a Docker one right up top. So I can click that in it. Now, I'm going to turn back to the one I had for a moment, just because I changed the workspace root. Notice on line 20, I'm pointing to the folder where my node server lives. That's the real important one here. I'm attaching to the right port, looking at my container. I want to look at my local code so I can debug what's in the container mapped to my local source code. Then I simply select Attach the Node. I press Run. It's going to attach the running instance. We'll pull this down. Let's go over into my routes file. And here's my route for getting heroes. We'll go back to the browser, and let's refresh the app. And bam. Now we're debugging inside my Docker container. I can examine the variables. I can change them if I have watches on them. I can look at all the local variables and explore them and do anything else that I want to do. Step through it, continue, and move on. So that makes me feel good, right? I feel like now with Docker, I have this comfort level of I can do everything I need to do without learning CLI commands and other stuff from terminal. Right inside my tooling, I can do this. And I still have access to the files, the logs, and debugging. Awesome. So now we've done it local debugging on it. Assuming we feel, wow, that was back to the first slide, okay. Let's start over. Just kidding. So assuming that makes you feel better, then the next step is, all right, let's see that container run everywhere. So we ran Docker Compose. That's what happens when I did it through the command palette. You can run these yourselves through the command line as well. Once we go to the cloud, we want to tag the image. The tag helps us because now we can say, where's it going to live? Just like node modules live in NPM in the cloud, we can take those up there like Maven for Java or NuGet for .NET. There's a registry concept for containers. There's Docker Hub, which is a public one, or you can use one on Azure or a private registry at your own company. So you can put your containers in them. So we tag it with the name of where we're going to send it and the image, and then we push it to that registry. That puts it up in the cloud for somebody to use. And then somebody can just grab that and stick it onto a website. So the next step would be, I'll go back into our tool. This was, okay, here's our Angular app. Let's say we've got this container over here. Now, I don't want to expose that debug port, so we can run Docker Compose up again. This time I'm going to choose the regular Docker Compose file. Let's go look at that one. You notice this is slightly smaller than the other one. It just puts a production flag in there, gets rid of the debug ports, and runs node index as opposed to the inspector. So this Docker Compose is building the same thing. It built pretty quick. It's running locally right now, but look what I can do now. I can take my image, and I can also prune, by the way. Gets rid of all those intermediary layers. Clean up my images. I can then take it, and I can tag it if I want. So I can come down here, and I can tag any one of them. I could say tag image, and it puts the name of it up there. And then after I tag it, I create a new version right there. I can right-click on that, and I can say push. Now those little CLI commands I ran before, they're running right now through the Docker extension. So you can run them from a terminal, or you can just right-click and do it this way through the extension, which is nice. So obviously you have to log into the server where you're going first when you push it, like if it's Docker Hub or Azure, anywhere else you're going. But that's nice. So now push my entire container up into the cloud in my registry. This extension also has a registries down here, and I pushed it to Azure. So it's logging into Azure now for me to see what's in my container registry. That was the name of it. I should have an image up here for our Angular Cosmos app once it comes back. And then once it shows you that image, what I can do in that registry is I can then right-click it and deploy it to a web app right from here. So I can say, okay, take what you've got right from here and deploy it to the cloud. I'm going to refresh again. Looks like it's having internet connectivity issues. Nothing like giving a cloud demo when you've got internet connectivity. All right, we'll give it a few seconds. So what we want to really do is that lets us do it locally, and that's really cool for local. But what happens if I'm the guy who built that, but then you need to build it, and I'm out to lunch, or I'm talking at a conference like this? Who's going to push our code to the cloud? If it's always done locally from your machine, it's kind of hard to automate that. So what we really want to do is we want to be able to push code to like GitHub, put in a master or a production release branch, and then have GitHub notify our CI/CD server. It could be Jenkins, Travis, CodeShip, VSTS, whatever your favorite one is. And then that does your build process, builds your Docker file, same thing we did locally, sticks it in a container registry, and then automatically pushes it to a web in the cloud for you. It'd be nice if you could just, all we're doing in that case, commit our code. Push, do a merge, and then just go look at the browser and it's there. That'd be great. Then it doesn't matter if I'm out to lunch because anybody else can run it. I guess that's not job security, but that definitely helps automate. So let's take a look at how CI/CD works. We'll see if that tool came back. It's still thinking, look at that. We're going to refresh the whole tool and see what happens. I do not control the internet, although I wish I could. All right, registries, Azure. I see it spinning and thinking. And yep. Oh, yeah, look, that came back. And now it's thinking again. Oh, there it is, cool. So I can look inside of this. That's my Angular version of the application. There's my tag for latest. I can right-click it and deploy it to an app service. This is pointing to Azure because it's in an Azure registry, but you could do it to any cloud provider through the other ones like Docker Hub. Resource group is something I can pick. I want my Linux one. That's like a logical organization of where they can go, or I can create a new one. I can say the Papa DevFest group. Oops. Create a new source group, give it a name. Where do I want to put it? We can put it in Southeast Asia. How's that sound? And then we could stick it into a service plan, or we can create a new service plan. Who wants to spin up a really expensive server with me? All right, let's do it. I'm going to name it so I can get rid of it later. Let's go for an S3. That means lots of processors. Now let's give it a unique name, the Papa DevFest app. So down below, you're going to see what's happening. It's going out to Southeast Asia. This is where I imagine Scott Guthrie sitting out in a server, waiting by the phone. He hears the call. He's like, oh, somebody wants a new server. And he gets up, spills his coffee, runs over, gets a server, plops it in the machine, spins it up, and then we have a new web app. Well, what's actually happening there is they're provisioning a new server, and it's going to use the image from the container we pushed to then spin that up inside the cloud. Now, while that's happening, let's go look at an existing one that we have. So once it's there, oops, wrong one. There's also an extension for Azure App Service, which I can log into. And see, it's already spinning up. That's cool. I can go into the app, and you're going to see something kind of neat down here. Application settings. Remember I said this was a production site. I'm looking for environment variables. How do I set those? Well, I can right-click right here and add my environment variables. So I could say, hey, node env, and that's going to be production. Now, I've got database settings and connection strings and other stuff there, and they'll all appear as well. I'm not sure if the machine was entirely spun up when I did that. We'll find out. And then once you're done, you can just click on this and run to it. It shouldn't hit the database because I didn't set up all the strings for that quite yet. But let's go back here. And let's refresh it. And hopefully it saved the one I had. If not, we'll look at a different one real quick. So here's another one with some application settings. Hopefully my keys are hidden. There we go. Now my keys are hidden. I'll have to change those now. Darn it. But you can see in node environment, there I got my Cosmos DB ports, database connection strings. You can set all that right here. Never had to leave my tools, which is, to me, pretty cool in the application. But again, that's local. How do we do this with production code? Let's go up to CI/CD server. I've got another app here, this Angular app. Let's kill this now. And let's say I wanted to view this in the cloud. Now notice this one is our Angular application hitting Cosmos DB. I've got this custom URL called secureheroes.com. And yes, I have a site called Insecure Heroes too, because heroes are humans. And let's see, is it going to spin up? Definitely having connectivity issues here. There we go. It's thinking. Go over to network, refresh. I changed the database key, so we're not going to see them there. But we can see the app title there on the application. So it's spinning up. This is what's running in production. I want to make a change to the app title. So what I can do is come over here to my app. I can then change this to Hi DevFest or FevFest, however you prefer. We can type in here and say new title because. And I can push. Now what I want to happen is when I'm pushing this and it gets up to GitHub, assuming it stops that little blue line, it did, GitHub should see that change. Okay, so then I take my change over to GitHub. Let's go check that out. So it's an Azure samples, Cosmos DB. I was using the develop branch, and we'll go look at that branch real quick. Where's develop? Down here. And you can see less than a minute ago it made it up to here. Great. Now here's my CI/CD tool. So if we look inside my tool, we can click down into a process that's looking for this. And I go up into my builds. And then for that build, I've got this Docker build. Notice it says in progress in the status. I can click on edit. What's happening in this build process is, okay, I'm watching GitHub through this trigger. This trigger's enabled. It's got a Git hook. It says when you make changes, I'll go look at that. What am I doing when that happens? Go get the source code. Easy enough. Run Docker compose. Same thing I did locally. Push to the Azure registry. We could put that in a release if we wanted to. It's probably more appropriate in the release as well, so we can control it with automated approvals. So once GitHub's done, this build's going to be happy. So if we go back to the builds, we can watch it. It's in progress right here, build number 197. Boy, I build that thing a lot. And then right here you can see what step is in. We're running for about 70 seconds. This usually takes about 2.8 minutes to complete. Once it's done, what's going to happen? It goes to the Azure Container Registry. And then I have a website, the one that we looked at, Secure Heroes, which is looking at that registry saying, hey, when you get a new version of this container, just pull it in, restart the server, and let her rip. Now, what if you didn't want to affect that in prod? Like, you probably don't want everybody in your company just pushing to a branch and it just goes to production every time it happens. Or maybe you really do, I don't know. But and this, what you could do is you could have like slots. Azure has this idea of slots in the cloud where you can have like A and B or testing and load. Other clouds have the same thing. If your cloud doesn't have slots, just set up separate servers, one for testing, one for production. And you can have your CI processes go between them. The cool idea behind slots though, which a lot of the clouds do now, is that if you have an A and a B slot, you can keep your A one running production, you deploy this to B slot, And with a different URL, you can check it out, make sure it's working. Once you're happy it's working, you can flip it over or use a load balancer to flip if you got like a light and dark. You want to do something like that. So depending on how complex your CI and environment is, you can do all these things. If you're literally just somebody who's like a two-person shop and you both want to control this and you want to push to prod, then this will do the job for you as well. So it's running through here. It should be just about done. The npm installs take the longest piece of building these up. And it's almost done because it's got through Z. It's copying the files, moving them over. We'll go look at the slides while it's finishing up. Oh, there it goes. Cool. And now it's going to push it over to the Azure Container Registry. And then when we're done, we should see all green arrows on the left. Cool. Now over here, it's reloading this app. So usually it takes a couple seconds. It's actually reloading the server behind the scenes. And once it's reloaded, we should see the new title for the application right there, live in production, which is pretty cool up there. And I've done this demo so many times now that I had to change the login to only allow me to make changes. Otherwise, people started putting really bad things up on the screen while I was doing this. Security is a good thing, isn't it? It is a thing. All right, so we now showed several ways we can do this. The nice thing about Docker was we could run it locally and debug it. We could run it locally and push it directly to a cloud server, or we can use like a CI/CD process with source control to get it up there. And it's all the same Docker file. So again, the idea here is we build and run and debug locally with Docker. That gives you that comfort level of making it work. It also means that if things aren't working right, I can debug it locally instead of doing it in the cloud. Then I can use CI and continuously integrate it and then continuously deploy it using tools like Jenkins or VSTS or CodeShip or Travis or whatever your favorite CI/CD tools are. They all work. And then host it in a cloud with any cloud provider that you want. I use Azure because it actually works pretty cool with containers. And finally, just kind of wrapping where we came from, JavaScript is, as I said, has evolved quite a bit over the last decade or so. And with that came a lot more features. And a lot of these features came out because so many people are using JavaScript because it just works everywhere. It's great because we finally have that language that works in the server, the client. It's awesome. But with that, now we're writing so much code, we need to be able to optimize our apps. And these CLIs really help us do that. And where they can't, then we have tools like these bundle analyzers and other source map explorers where we can really dig in a little deeper to find out how do we tune it. And then Docker just makes it run everywhere. I mean, we talk about Docker with Kubernetes and all these other tools, and they're awesome. But for me as a developer, I just want to make sure the code I'm writing works on all your machines. So these are the links that you can use to get everything that I showed today. There's links to documentation that shows exactly what I did up there, and there's 5 or 6 videos where I walk through the scenarios. You can go get the code. That's the second link. That's up there in the develop branch. Don't grab the master one, grab the develop branch. That's the one that I keep updating with new features. You can also get, if you like Angular, I've got a pack of essentials that works in VS Code, like snippets, really helpful. If you want to get the extensions I showed today, just hit that link for VS Code for Node for Azure. And some of those things are Azure, some are not. Like the Docker extension works with Docker Hub or private registries, whatever you want to do. Really, really cool stuff. And if you want to try Azure out, you can click that and get a free trial and spend free money. Who doesn't like that? With that, I want to thank you all, and I'll stick around for questions for a few minutes if you have any. Thanks.